What's the formula for angular momentum? Besides h bar. For physics 251, what is the formula for angular momentum?
The moment of inertia times the angular speed.
Yes,
Frequency.
or velocity. But if I have a single point particle, an electron's not really, all they've come up with for the size of an electron is that it is less than some limit. So the electron is pretty much considered to be a point particle, rotating about this center point. What is the moment of inertia of a point particle? A distance r away from the center. What is the formula for moment of inertia?
Depends what it is, right?
Yeah, the generic. The one from which we derive all the others.
mr squared.
It's the sum of all the mr squareds, or for calculus, it's the integral of r squared dm. You basically break it up into infinitesimally small pieces, and the mass of those infinitesimally small pieces times the radius of the curve, the radius of the rotation. Well, if I just have a point particle, it's already broken up into an infinitesimally small piece. So that's just mr squared times omega. What is the relationship between angular speed and speed? Between v and omega. So it was like this, I'm thinking, if I'd done flash quizzes in 251, would you know it?
Estimate involves 2 pi, is it?
Not in the simplest form.
No.
All right, what about if I have a circle here with some angle theta and some arc length s and the radius r? What's the relationship between arc length, angle, and r?
Arc length is equal to r theta.
Yeah, s equals r theta. If I take the derivative with respect to time, so ds dt
Speed.
is equal to r d theta dt.
Angular speed.
Yeah, omega. V equals r omega. So this is going to be equal, well, I take one of the r's and the omega, so I get m r v, or as usually written in VR. So I have this mv times the radius is equal to n times h bar. So n h bar is equal to mv bar. It's that point where I start to feel rushed. Why don't we? Now we can get at least the first part. All right, so we have this relationship here. Again, I got my nucleus here. I have an electron that's zipping around. Let's bring in some more concepts from mechanics. Force diagram. What are the forces acting on the electron?
Gravity?
The gravitational force acting on the electron is going to be so insignificant that we will ignore it.
Centripetal force.
Okay, what is the centripetal force in this case? This is a physics 252 topic. That's the one. So I have this electric force acting here and electric force acting here. Now, if I just simplify this down to a hydrogen atom, I have an electron and a proton in the nucleus. The proton is 500 times more massive than the electron is. So I'm going to assume that the proton's not really wobbling a whole lot. You know, it's like Earth going around the sun. Yeah, the sun wobbles a little bit because of the Earth, but not significantly. So I have plugging into F equals ma. Towards the center is going to be the positive direction, so I have K, or 1 over 4 pi epsilon naught. Charge of the electron times charge of the nucleus over R squared is equal to M centripetal acceleration. That's angular acceleration.
And V squared over R?
V squared over R. Well, I just happen to have a value for V over here. So V is equal to NH bar over MR. V squared would be N squared H bar squared over M squared R squared. Pop that baby into there. And so, and let's get rid of at least one thing here. That R cancels out with one of those. So I have E squared over 4 pi epsilon naught R equals M times N squared H bar squared over M squared R squared. That N cancels out with that. That R cancels out with one of those. And I am left with, that's all I can cancel out. So now, R is equal to, bringing that up, this down, so I have H bar squared 4 pi epsilon sub naught, permittivity of free space, divided by mass of the electron times the charge, the base charge squared, times N squared. This, let's just whip out the calculation quickly. So H bar squared, 6.626 times 10 to the negative 34th over 2 pi times 4 pi times 8.85 times 10 to the negative 12th divided by mass of the electron, 9.11 times 10 to the negative 31st. Charge of the electron slash proton, 1.6 times 10 to the negative 19th squared. And we get see if we can do better than the 152 class, which got 3 different answers. So cool when all 5 of you get the exact same number.
It got 3.16 times 10 to the 24th.
10 to the 24th?
Yeah.
No.
Oh, wait.
Or unless I made a mistake here, let's see.
23rd. I mean, 5.0.
Something's off. So R goes up, got H squared, oh, this is squared. That, okay, sorry about that.
Got 5.3 times 10 to the 11.
5.3 times 10 to the,
11.
not negative,
Negative 11, yeah.
units.
Meters?
What'd you say?
That's the radius, right?
Yes.
Meters?
This is known as the Bohr radius. And so what Bohr has now predicted is that the radius of an electron is going to be 5.3 times 10 to the negative 11th meters times n squared. This number right here, generally represented by a sub 0. If you've got chemistry, they've talked about quantum numbers in chemistry. N is the first quantum number. It's the shell. From this, we'll be able to predict the energy of an electron, and then that will lead to, so this assumption right here, yeah, we'll get the energy, which will lead to the discrete spectra and why electrons don't go crashing into the center. But that's gonna have to wait until Monday. And hopefully I'll remember, I do want to finish this up on Monday. I'll bring in some equipment so at least you can see the discrete spectra for those who have not seen it before. And hopefully you'll win by this time.
So our final is gonna also have quantum physics in it.
It is fair game, but there's only so much I can, there's limited time and quantum physics, there's a limit to what I can ask.
It's not a question, more just about what